Mitsubishi product specialist here at Olympus Controls. And today what I want to show you is Mitsubishi's FR Configurator2 software and how to set that up with an E800 VFD, as well as what I have here is a 90-watt induction motor. So I have this all connected through a USB mini cable, which is what the E800 uses. And lucky enough, with the E800 as well as the new D800 series, you can program those drives with just the cable alone. You don't need to provide line power to power the control board. You can do that if you prefer, but when you got those 480 volt rated drives, it could be a little bit more tedious to have that at your desk. So I've just got this USB cable plugged in. We're going to be able to program the drive. And then what we're going to do is we're going to do a simple just startup and tune the motor and show you some quality of life parameters that you might run into and think, oh, maybe I set this up wrong. Not to worry, you're just a parameter or two away from getting to where you need to be. So when you go to get in the software for the first time, this is the screen you should be met with when you have a new project. And it's going to start by asking you, what sort of connection do you have? USB is typically what I recommend. It's the most common. It's the easiest to set up. I don't need an IP address for my USB, whereas with Ethernet I would. So we'll just stick with USB for now. You can also go through other devices such as GOT or PLC. Typically, I think you might use a GOT if maybe that's on the front panel of of a panel. It's mounted up there. You can plug right into the front USB, and if it's connected to the VFD, you can try to communicate to it that way. That said, here's the model setting. You can go ahead and drop this down and find the model number. If you're like me and you want to do this a little more easily, I would just do an auto recognize, say, yep, go ahead and clear the data that's in here. I don't have any data in here. It's brand new. And it'll start cycling through all the stations, trying to find anything that it can see through that USB connection. But we've only got one drive and it's already populated, so we can go ahead and cancel this. And we'll just scroll back up, verify that this is your correct part number, and for me it is. So we've got a 1 horsepower drive here, and I did mention we had a 100-watt motor, and that'll come into play later. So we'll click OK here, and you'll see this project window populate. We do need to connect to the drive, so make sure you click this, otherwise you're not going to be doing anything as far as communicating to the drive. And we've got a big workspace over here that has nothing in it, so let's go ahead and populate that with our parameter list. And if you haven't done anything on a VFD before, or even run into how many parameters are on these, this can seem very daunting at first, but don't worry, I'm going to show you what we need to do, and you'll feel a little bit more comfortable after this video. So let's do a batch read. We want to read everything at once. You can also individually read if you want, but all of these are blank, and I want to get all these setting values filled out. And the reason we do this is, one, we got to see if anything's been programmed on the drive already, or two, maybe I'm going to troubleshoot this drive. I should back up the file that's on that drive first and foremost, save it, start a new, or save it as a new project. That way, if I do make any changes, I'm not affecting the program that was originally in there. Just typical troubleshooting 101. So now that we're in this interface, let's go over how to set up the motor. Now, you can go in here and manually set this up if you know where the parameters are for it. This would be our motor FLA. But if you're using this for the first time, you're not going to know that parameter 9 is set up for that. And you also don't know that the rest of the motor parameters are down at parameter 80. So without looking in the manual, you're probably not going to pick that up right away. But not to worry, we can actually we can set up the motor from here. We have a wizard here that'll pop up. You want to indicate your motor type. For the most part, you'll be fine just using Mitsubishi Electric standard motor. There is the other standard motor option, but the way that these values record, it's better to do the Mitsubishi Electric standard motor. This one will actually use engineering values, so you'll get your ohms and your amps and all the typical units, electrical units that you'll have tied to a motor. So I'd recommend doing this one unless you see your motor part number here. So if you see you have an EMA, definitely do the EMA. Same thing, IPM. If you see the motor in here, make sure you pick it. We're going to leave this here for now. You can do a VF auto tuning, but we're not going to do that today. I want to do something a little more sophisticated. You have real sensorless or advanced magnetic flux vector, which are very similar control modes. One's a little bit more sophisticated than the other. We'll pick the middle of the pack one. And all this control method really does is if, let's say the motor's running at like 12 hertz and I go to grab the motor shaft while it's running, it's gonna dip momentarily as I grab the shaft and slow down, and then it will ramp back up, trying to overpower me adding resistance to it. So this is how it would differ from VF mode. And the real sensorless vector does this a little bit better. But we're just going to do this with advanced magnetic flux vector because the process for setting this up is the same. Our capacity, I mentioned I had a 90-watt motor, but the unit range is from 0.1 to 30, and that unit is kilowatts. 100 watts is pretty close, so for all intents and purposes, this is fine. We do have a 4-pole motor. This is the rated current that the drive has listed, but we're going to put in 2, and the motor itself is actually rated at half an amp. Now, the reason we're doing 2 amps instead of half an amp is because we need to be within 40% of the rated current of the drive. Now, the reason that I have to put 2 is because, like I said, we need to be within the rated current of the drive. And if we don't, the tuning actually won't get done properly or at all. So after we finish the tuning, I will go back and change this myself and make sure that our motor FLA is what it should be. But this will allow us to get the rated values within the drive after, or I guess during, auto tuning. So it's a 230 volt motor, 60 hertz, great. So we're ready to move on with our life. Do you want to finalize this? Absolutely. Go ahead and put those numbers here. And you'll see the numbers in blue indicate that it is changed from default. So that number is here. So you'll see these motor values have also been updated. Great. So we're just about ready. I will cover another parameter, which will make our life a little easier. If you're going to use this for the first time, it is important that you know these operation modes. Why these are important? These are the ways that the drive is operated, right? So as obvious by the name, PU stands for parameter unit. So this will either be on the front panel of the drive, or maybe you have an external parameter unit that you have. It could be mounted on the panel that this drive is in. Or if you want to communicate to this over the USB cable, this is the setting you're going to use. So this is going to be the most common one you use when initially setting it up. We do have EXT mode as well. EXT mode is our digital input or analog input control. So it's basically giving permission for the terminal blocks to control the operation of the drive. Then we have net mode. It's not going to allow us to do this just because I haven't set up the net mode. There's a little bit more involvement in making sure we have the right operation mode set up, as well as the communication settings, which none of that's set up because we're just booting this drive up for the first time. So we'll go back to PU for now. Actually, let's go to EXT. I'm going to show you something here. So instead of 120 for our maximum frequency, let's go ahead and type 60. And none of these values have been written to the drive yet. So I'm going to try to write this. And, we got an error. We can't do that. And the reason being is what I alluded to earlier, which is we need to be in PU mode when we're programming this drive. Now, this is going to probably start to annoy you after a while. And, having to remember to swap back to this all the time, especially if you constantly have the drive in EXT mode. So what we can do to alleviate this is that we have a parameter right selection that we can do. And by default, it's set to 0. We're going to go ahead and set this to 2. This basically says, hey, I'm the admin. Let me do what I want. I want to write these parameters. Let me do it. So we'll go back up here. This still has not been written, and I'll prove that to you. We'll read it from the drive and say, what do we have? 120. So it never went through. So let's go ahead and write 60. And we will hit that right button again. And we're still in EXT mode, and we did write the value. And it's even asking me, do you want to refresh the display? Normally we'd say yes, but due to time constraints on the video, we were not going to do that for now. All right, we are just about ready to go. Let's go ahead and set up the auto tuning value as well. Now, you have the option. There's a few ways to do this, and what I'm going to show you is this is a software that comes with FR Configurator, and it is called eManual Viewer, and it comes with some of the other software suites as well. But when you install it, it'll ask if you want this. I highly recommend you install it. And what it does is you can download the manuals to it so you have them locally saved. And if I double click on any parameter, it will show me the parameter as well as associated other parameters. And it can help point you in the right direction for what you might be missing or give you a little bit more details. So because we're doing auto tuning, we do need to set probably 1, which is where we're basically auto tuning the motor without rotation. Occasionally, you may want to do offline auto tuning with motor rotation. That can sometimes help out in case this tuning doesn't work. So something to keep in mind. And you can do VF control tuning if you're going that route. But I mean, if you're going as far as to tune the motor, I'd probably recommend you do something a little more sophisticated like the real sensorless or the advanced magnetic flux vector. So we'll go ahead and minimize this for now. We'll go back. We'll try 1, which is the non-rotational, and we'll see how this goes. We've got all our values. We should be ready to go. So let's go ahead and do a batch write. Now it'll take a minute. We have to do 582 parameters here that we're writing to. You can also individually write these with the right button here. Um, but it just depends on how many you've written. If you've written a lot, you're probably not going to want to sit there. And this gives you a good opportunity to stretch. Maybe go get some refill on coffee like I do. But yeah, so this will populate if anything doesn't get written, which we should see here. Here's this refresh display again. Normally, again, we'd say yes to say, hey, go ahead and update anything that got changed. We'll say no for now just for time constraints. This is a non-consequential error. You can look into it if you want, but take my word for it. This isn't something you need to worry about. And we don't want to be overwriting the maintenance timer because this indicates how long until maintenance may need to take place. So we'll close that for now. We are good to go. Now, from here, we can go into our test operation. On the drive, you should see that parameter 96 auto tuning number, in this case was 1, is displayed on the display of the drive, indicating we are ready to go. We are ready to start tuning. And you can do this a number of ways. I like to do it through the test operation. I like to have the keyboard and mouse. You can do it from the display. And I believe you could even do it through the EXT control. But easiest way to do it is doing it this way, in my opinion. So we'll go into PU mode because even though this works for programming, we are trying to control from the USB. So we do need to be in PU control, at least for operating the drive. And I highly recommend you uncheck this box for testing purposes. Otherwise, I mean, if you leave this checked, you basically have a dead man switch and you can hold this down. But if you let go, it will interrupt the auto tuning and you'll have to set the parameter again. So we'll set the forward rotation. And if you listen closely, you may not have to listen too closely. You could probably hear it in the background while I'm talking. The motor is going through the tuning process. The number on the drive should change from 1 to 2, indicating we are in the middle of tuning. If everything goes well, you should see a 3 populate. It does look like we're done, and unfortunately, with this situation, and normally you should see a 3 here, but I'm getting a 93. This actually is an error indicating something's wrong. And it's likely due to the mismatch that I have. So what I'm going to do to try to get around this is we're going to go back to that 101 setting, which was our allow rotation during the auto tuning. Now, in both cases, you really don't want to have the motor connected to anything. Even though it's not rotating, it's still just better to have the motor isolated. Just run the tuning. Once you have all your values, go ahead and hook it up. Then you can hook it up to the load and run it the way you want to run it. But now that I've written this value, or I guess I haven't written it yet, let's do a write. And, oh, you know what we're missing here? This is important. We need to stop the operation command. We cannot, it's still given the go command because I don't have this set up as a dead man switch. So let's go ahead and stop it. That command stop. And now I can write to it. We can't change the auto tuning when I'm commanding the motor to run. All right, so now I've got 101 on the display of the VFD. We are ready to go and give this a shot again. When we're doing the rotational auto tuning, it is a little bit, it takes a little bit more time. That other one was pretty quick. I'd say it was probably 10 to 20 seconds maybe. This one, I believe, takes closer to 20 to 30 because we do have a whole process for the motor to start running and spinning the shaft. So another good time to take a little break while you're waiting for it and everything goes well. Instead of 3, we should see 103. So it goes 101 to 102, indicating a tuning's happening. 103 indicates everything went well. I'm spinning up to speed. I believe the speed we're referencing here is not so much this one, so you can pretty much enter any value you want there. It should be referencing our maximum frequency value, which we have to 60, so that's what we spun up to. Now, we're just about done with the tuning. I got a 103, that's good. Remember, we got to stop this. We'll go back to the parameter list, go back to our 96 parameter, and just so you know I'm not making it up, let's read the parameter, 103. All right, we're good to go. Now, what did that do? So we'll do a batch read, and now it's gonna update all the parameters we had. This one will also take a second because we're gonna basically be reading all of it at once. And once that's updated, you'll have all your values here. These are all the motor constants that the drive determined were appropriate for the motor. So now the motor's tuned and ready to go. Let's go ahead and test the operation. I'm gonna change this actually to 40 hertz because I want to see if I can get you to hear it. And see how loud it is. So out of the box, the motor's not going to probably sound too great without changing anything. As I mentioned previously, we want the motor, the motor will run out of the box, but we need to fine tune it with some of these other parameters. And the biggest one is actually changing our carrier frequency, or as it's listed here, the PWM frequency selection. By default, this is 1. I'm going to set this to 15, and this is just changing the resolution of that carrier frequency. It's by default very coarse, and you're probably thinking, well, why wouldn't I just set this to 15 right off the bat? Well, the reason is because the finer that resolution is, the hotter the motor is going to get. And you're kind of basically doing a comparison between, do you want the motor to run quietly and hot, or loud and maybe not as hot? So you're going to have to play with this number, try to figure out what works for you. I don't think that I wrote this yet, so we'll write it again just in case. And now I'm going to run it, and I want to see if you can actually hear the noise difference between the two. So you get more of a high-pitched whine, which you can hear from the carrier frequency, but we are up and running. This motor's ready to go, and now we can actually start messing with other parameters if we want, for whatever the application is. But yeah, that's really it. That's all we're doing. I'll go back and change my parameter 9, which is my motor FLA, to what it should be, and we're good to go. That's really it. So if you have any questions, reach out to Olympus Controls. Again, my name is Bryan Morrow, and I'm the Mitsubishi product specialist here at Olympus Controls. Thank you for your time. Have a great day.